So let's go ahead and practice some of this holy trinity of continuity on the next page. We're going to go ahead and analyze this graph, and we're only going to take a look at 3 specific x locations. Now, since we have a graph, you can definitely see, based off the picture, whether it's continuous or not, because we can identify where holes, jumps, and asymptotes are located. But I want us to get used to using that 3-part definition, okay, that holy trinity, when analyzing and defining whether a function is continuous or not. So just by saying there's a hole, a jump, or an asymptote is no longer an acceptable reason for a graph to be discontinuous. Okay, we have to state which one of the 3 parts is failing, okay, or not happening appropriately in the graph. So we have to use this 3-part definition, the holy trinity of continuity. Taking a look at the x location of -8. So our first part is, does the point exist? So if you were to plug in -8 into this graph, would you get out a point? So if we take a look at -8, we have a graph there which has a height of -7. All right, so the point exists. We have our bridge, if you want to think about that example. The second thing we got to check out is the limit. So we got to check out the overall limit. As we approach this -8 from the left-hand side, what does the graph do? And as we approach -8 from the right-hand side, what does the graph do? So approach negative, oh, I'm looking at the wrong one. Look at me get on a roll. Here's -8. I was doing -6 before. -8 is at the hole location, and it looks like we do have a function value, though, that's 4. Almost got off on the wrong start there, but I caught myself. So let's take a look at the limit. As we approach the left-hand side, we approach the hole, which has a height of -5, and the right-hand side also has a height of -5. So we can say that the overall limit at -8 is -5. So notice how we have a point existing and a limit existing, so we have a bridge and we have a road. We got to check out, do they actually meet or match up? Notice how the point is at 4 and the limit is at -5. So clearly the point does not equal the limit, so therefore we must be discontinuous. So we can go ahead and say g of x is not continuous at x equals -8. Now, you don't really have to say because the point did not match the limit. This analysis, this 3-part definition, is basically your justification for whether it's continuous or not. So this would suffice for showing your work. Let's go ahead and try the location of -6. So 3-part definition, does the point exist? If we plug in -6, there we go, that's the same point I was doing before. We got -7. So the point exists. Let's check out the limit. So we have to approach the left-hand side, the right-hand side, and then that should tell us something about the overall limit. So left-hand side of -6 looks like we approach a height of -7. Right-hand side of -6 looks like we approach a height of -7. The left and the right side are the same, so the overall limit is -7. So we have a bridge existing, we have the road existing. The kicker is, do they match? Notice how the point is -7 and the overall limit is -7. Those are equal. So our graph is continuous at the x value of -7. So g of x is continuous at x equals -7. And we can even confirm that on the graph, because if we take a look at -6, notice how there's no hole, no jump, and no asymptote at that location. So I know visually we can see it, but we need to confirm it mathematically, okay, using this 3-part definition. Looking at the last one, we're going to try the x location of -4. So does the point exist? Yes. Oh, that's +4. Here's -4. We actually do have a point here, closed circle at -5. Let's go ahead and check out the limit. So if we approach -4 from the left, then we got to check out the right, and that should tell us something about the overall. All right, so -4 from the left, we approach -5. -4 from the right, we approach -2. The left and the right side do not match, so the overall limit does not exist. So notice how the second rule of our Holy Trinity fails, because we said the point needs to exist, but the overall limit must exist as well. So going on to number 3 is not really necessary because number 2 failed. So we can say g of x is not continuous at x equals -4. Again, we can confirm that on the graph because notice how at that location we would have to pick up our pencil because we have that jump.